Okay, today we're going to be talking about more of the natural log, but we'll be doing integration with it. So I want you to look at the main concept here, and that is that if you integrate 1 over x dx, you get ln absolute value, and the reason why the absolute value is because natural log is always positive, plus c. Now, we've never integrated this before, and if you look, if you have x to the negative first, you'd be raising it to the 0 power once you raised it by 1 and putting it over 0. You cannot do that. It's considered undefined, so you have to have a special rule for this. And so the integral of 1 over x is ln absolute value of x plus c. So let's just jump right into doing some problems. We're going to treat these as the same we did with the integrals we've done in the past. We're going to say we can bring the constant out front still. And we have 1 over x dx, and then we can just go ahead and integrate this and say, well, there's the definition we just gave to the integral of 1 over x. It's the ln of x plus c, and I need absolute values around it because ln's always positive. Moving on to the next example. This one is going to require me, because if I write this as 4 minus 3x to the negative first power, it's not possible to do, so I need to go ahead and make a u statement out of this. So I'm going to let u equal 4 minus 3x. So that means my du is equal to negative 3 dx. Now I'll go ahead and rewrite this integral in terms of u. So I've got 1 over u. I only need the dx part, so I need to put a solve for the dx and put the negative 1/3 on the other side. So that means I need to add in here a negative 1/3 du. So I'll go ahead and integrate this now. When I integrate this, I get negative 1/3 ln of the absolute value of u plus c. Last thing to do is just substitute that back in. Squeeze that in right over here on the side. U is 4 minus 3x plus c. So there's my solution to that problem. Here we have another example. In this case, it looks like I need to do some sort of a u statement. So I'm going to go ahead and FOIL or distribute out that top, just to get a better look at what's going on. If I had to guess where I was going to make a u, I'd make the bottom u. So we'll go ahead and try that and see if it works out. U equals x cubed plus 3x squared minus 4. So my du is 3x squared plus 6x. Now I'm going to have to look pretty hard at this to notice that that is what's up on top. If I just factor out a 3, I'll be left with x squared plus 2x. So we'll go ahead and rewrite this integral now as the bottom's u. I need just this portion right here, so I'm going to go ahead and move my 3 over, which will give me a 1/3 du is equal to an x squared plus 2x dx. So I'll add in my 1/3 du over here, and I'll put 1 on top. So I end up with the answer of 1/3 ln absolute value of u plus c, and now I'll just substitute that back in. So my final answer would be 1/3 ln absolute value of x cubed plus 3x squared minus 4 plus c. Alright, so we're going to continue doing some more problems. This time, if you start to look at these, it's going to be hard to make a u statement out of either one of these. If you make this be u, you get 4x plus 7. That's not going to help cancel the bottom. If you make the bottom u, it's not going to help cancel the top. So this is one of those problems where we're going to actually use long division as a technique of simplifying. So off to the side here, you can see me using the long division. So I'm going to say, what times x will give me 2x squared, and I'll answer 2x. So 2x times x is 2x squared. 2x times negative 2 is negative x. So I'm going to subtract those amounts off. So I have 7 minus negative 4, which is 11x, minus 3. x times what gives me 11x? Well, that would be 11. So I have 11 times x is 11x, and 11 times negative 2 is negative 22. I'm going ahead and changing colors so you can see that I am subtracting 11 minus 11 and negative 3 minus negative 22, which gives me a positive 19. When you're finished, you always write the remainder over the divisor. So we have 19 over x minus 2. That will make this integral rewrite into 2x plus 11 plus 19 over x minus 2 dx. And now we're ready to go ahead and integrate this. So I will raise the first one by 1 and put it over that new power, plus 11x, plus I have 19. This is really, you're creating a u statement. U equals x minus 1, except that du is equal to dx, so it doesn't really make a difference, and we can just go ahead, well, it's the ln of absolute value of x minus 2 plus c. New example here, I've got a much bigger polynomial. I am going to need to use my long division over here. When you long divide, you've got to add in those zeros if they don't exist, so you have them in descending order. I've got x cubed minus 3x squared plus 4x minus 9. So I've got to ask myself, what times x squared gives me x cubed, and that would be x. X times x squared is x cubed. And then I have plus 0x, and then I have plus 3x. When I subtract that whole quantity, I end up getting negative 3 minus 0, which is negative 3. Well, I left my squared off here. Negative 3x squared. X times 3 then, or x times 3. 4x minus 3x is an x, and then I'll break down my minus 9. I will then say that a negative 3 times x squared is a negative 3x squared. A negative 3 times 0 is a 0x. And a negative 3 times a 3 is a negative 9. When I subtract this time, I end up getting 0 here for my first term. X minus 0 is x, and negative 9 minus negative 9 is 0. So I end up with a remainder of just x, and I'll put that over my divisor of x squared plus 3. So that allows me to rewrite this integral as x plus negative 3, or x minus 3, plus x over x squared plus 3 dx. This one portion right here, we're going to need to make a u statement for. So I'm kind of going to integrate this in this fashion. I'll think about each part separately, and then we'll go from there. So I need x squared plus 3. So my du is 2x dx. I only need the x dx, so I'm going to move my 1/2 to the other side. So I'll rewrite this integral as 1/2, 1 over u du. So when I integrate this, I get x squared over 2 plus negative 3x plus 1/2 ln of absolute value of u plus c. And my u is x squared plus 3, and everything else just comes straight down. This is a much longer problem, and some of them will be more complicated as we continue on. Alright, in this next example, I'm going to want to go ahead and reduce this just a little bit. I'm going to change this into 1 over x times 1 over ln of x cubed. And the reason why I want to do that is so I can go ahead and use one of my natural log properties, which says I can bring this out front. So I'm really going to have 1 over 3 ln of x, and then I'll have dx. Now, if you really look at this carefully, if you would just create a u statement of u equaling ln of x, you will exactly get 1 over x dx, which is what you need here. This 1/3 we can actually pull out front, so I can say this is 1/3, and then I have my 1 over u, this was u, and then I have my 1x dx by my du. So I can finish this off just by saying it's 1/3 ln absolute value of u plus c. So it's 1/3 ln of absolute value of ln of x plus c. The next example, we're going to have to do some sort of u substitution, so I'm going to go ahead and just try this parentheses here and see what comes to be. So I've got 1 plus x to the 1/3, so du equals 1/3 x to the negative 2/3 dx. So my integral is going to actually be I want to go ahead and reduce this over here first so I can look at it a little bit better. I need this portion right here. I don't need this 3. So I'm going to move it to the other side. The 1/3 I'm going to write as 3 du equals 1 over x to the 2/3 dx. So I'm going to put my 3 out front. And I'm going to go ahead and rewrite this as 1 over u du. And we'll go ahead and take the integral, which gives me 3 ln absolute value of u plus c. So I end up getting 3 ln absolute value of 1 plus x to the 1/3 plus c. This last example I'm going to try to get through in this video. I may not quite make it, so we'll see what happens. We're going to go ahead and go for a u substitution and let u be the denominator because it tells me to do that in the hint. I'm going to rewrite this as 3x to the 1/2 power. So that makes my du be 1/2 3x to the negative 1/2 times 3 dx. So my du ends up being 3. This is on the top, this is on the bottom, and then this is all on the bottom like this, dx. Okay, we're going to have to mess around with this in a little bit. What I'm going to do is I've got 1 over u, and all I need is the dx. So I'm going to have to solve this for dx. So if I want to solve this for dx, I'm going to have to multiply by the reciprocal. So I'm going to move this to the other side. So I get that fraction du equals dx. Well, that again is a problem because I can't substitute that in because I still got x's. So I've got to figure out what is x or something along those lines. So if I come up here, what I really have is I have u equals 1 plus the square root of 3x. So I could actually substitute the square root of 3x with a u minus 1. So I'm going to have to use this part down here. So I've got 2 now, and the square root of 3 over x is going to be rewritten as u minus 1 over 3 du. Again, I said this was a very complicated problem, and it is. So I've got my 1 over u, and then my dx is now going to be replaced with this 2 times u minus 1 over 3 du. And I'm going to have to continue this in my next video. So let's see if I can finish up this problem. What I'm going to definitely need to do is I'm going to go ahead and pull out this constant of 2/3 out front. That leaves me with a u minus 1 over u du. That means finally I can simplify this a bit. So u divided by u is 1, and this would be 1 over u. So now I think I'm finally ready to integrate this. I've got 2/3 times the integral of 1 is u minus the ln of absolute value of u plus c. So what I'm going to do is just substitute this back in. 2/3, my u is 1 plus the square root of 3x minus ln of absolute value of 1 plus the square root of 3x plus c.